first of all, I'm going to open my browser and click on USGS Earth Explorer. From this, I'm going to download my TM file for the study. So in this feature section, I'm going to select the address, and in this address bar, I'm going to type filtering and click on show. So as you can see, my area is being located. I'm going to further zoom in to the section. So this is CST, and below CST we have my study area, and which is Karbanti Gemba. Below this Karbanti Gemba, there is a valley where I need to find the volume of soil that needs to be covered in order to attain its stability. So I'm going to clear the coordinates and bring the coordinates here. I'm going to circle the whole area of my interest. So next, here my area is being covered. So I'm going to click on datasets. Since I'm creating the digital elevation map, so I'm going to click on it, and I need to use this SRTM. I'm going to go for the first option, SRTM 1 arc second global, and click on the results. So this is the footprint. I'm going to show my footprint. So this is the whole TM map which is going to be shown. So if I click on browse overlay, so this is my TM file. You can see this red one, it is my study area. So I'm going to download this TM. For downloading the TM, I'm going to go with this third option, GeoTIFF. And I'm going to name this as Yanra TM. Now I'm going to create a new project. To install my TM file in my project, I'm going to go to the layer section and click on Data Source Manager. In the raster dataset, I'm going to select the Gemba TM, which I downloaded earlier. I'm going to open and add and close. You can see my TM file. So to have a quick look at the location of the TM with respect to another base map, I'm going to open the OSM map. So you can see this is in the south, in the Finnsling area. To transfer the existing coordinate system of the TM from being a geographic coordinate system to a projected coordinate system, simply go to the raster option and click on projections and wrap my project. So my input layer would be Gemba, and the target coordinate referencing system would be Bhutan National Grid. So I'm going to leave other as it is, and I'm going to click run and close. You can see my projected TM file being created here, and there's a little bit of difference in these two elevations. So next, I'm going to go to the current CRS option here and select the Bhutan National Grid as my coordinate referencing system. You can see my TM file being located near the south area, so I'm going to apply this and click OK. So I'm going to remove this Gemba TM since I have this projected TM. So in the original TM, there will be some sort of distortions with the presence of sink. To correct the TM, we will fill the sink using the tools under Saga called Fill. So I'm going to go to the processing toolbar and type Fill. Under Saga, I'm going to click on this Fill Sink by Wanganlu. So my TM will be reprojected TM, and I'm going to untick this for direction and watershed basin and run. I'm going to close this, and you can see there is field theme. So there is changes in elevation, as you can see here, the difference. So I no longer need this reprojected theme, so I'm going to remove this. So this fill theme, I'm going to do some additions. So I'm going to click on the properties and select the single band fugitive color, and I'm going to go for the spectral, apply, and OK. To define the study area, I'm going to create a polygon or boundary that represents the specific study area within the value of corresponding gimbal. To do this, I'm going to go to the layer option and create a new shapefile layer. The file name would be area of site. And the geometry type would be polygon, and click OK. So in this map, I'm not getting a clear picture of my study area. You can see I don't know where my valley is in this OSM map, so I'm going to install the Google satellite under this XYZ tiles. I'm going to drag and drop it, and you can see my study area here more clearly. This is the valley of soil that needs to be calculated, so I'm going to create a polygon here. I'm going to click on this total editing and click on this add polygon feature. So I'm going to select this area. Going to enter the ID as 1. So this is my site area. Going to save the changes. Now to calculate the volume of the soil that needs to be covered in order to attain the stability in this valley, I'm going to go to the raster option and I'm going to clip raster by mask layer. The reason I'm choosing this clip raster by mask layer is because it focuses the study area more. So by clipping a raster using this mask layer, I can limit the analysis or visualization to a specific study area or the region of interest. So this allows me to isolate and work with the raster data only within the defined boundary, disregarding the areas outside the mask layer. Second, clipping a raster with a mask layer is often used to extract a subset of data from a larger raster dataset. This is particularly useful when you need to work with a smaller area or when you want to extract data for a specific boundary or study site. So since my area of site is very small, so I'm going to use this clip raster by mask layer. I'm going to set the input layer as the field theme, and the mask layer would be the area of site. And the source CR, I'm going to choose this one, and I'm going to assign this value as negative, which is out of range, this negative value. And I'm going to simply keep as it is, and I'm going to run it. as you can see here, there is my new TM, which is clipped mask layer, and the value are quite different from the earlier filled TM. This is because this clipped mask layer is only in my site area, and this clipped mask layer is in this rectangular form because the TM data is typically organized in a regular grid structure of rectangular cells. The next thing I'm going to do is search for this raster surface volume to calculate the volume. And as you can see, my input layer is already this clipped mask. And for the base level, I'm going to keep it as 368, as this is my lowest elevation in my clipped mask layer, and the highest elevation is 373. So this base layer would be 368, and the method I'm going to do is subtract the volume below the base level. So I'm going to save this surface volume report to file. This file is going to be in HTML. So I'm going to save it as volume. And I'm going to save this surface volume table to file as well. This one I'm going to save it as volume table. And I'm going to run. As you can see, my area is 1714 decimal meter square, and the pixel count is 2, and the volume of the soil that needs to be covered is 4285.32 meter cubic. So I'm going to close this, and to see the volume table that I've saved earlier, I'm going to go to my home, downloads, and to view the volume in HTML file, I'm going to click on it. And you can see the volume which is shown in this HTML file, volume.html, and the pixel count and area in meter square. So I'm going to close this, and if I want to double click this volume table, and this volume table has appeared in my layer panel. So I'm going to click this and right click. I'm going to open it in open attribute table, and here is the volume, which is in meter cube, and the area in meter square, and the pixel count. So this is how we find the soil volume by this clip raster layer.